Hello everybody, Nerdyology back here, back to another US National Chemistry Olympiad video. This is the 2019 exam, problems 25 to 36. So let's begin. So the first question is pretty straightforward. 25, acetone is bromate in acidic solution according to the following reaction. What is the rate law implied by the mechanism given below? So this is just a regular pre-equilibrium problem. So you know the first step is fast and reversible. So write the rate law, the rate of the forward reaction equals the rate of the back reaction. So you write this, K forward equals CH3CO acid reverse rate COH C3 plus. Now we take a look at the slow step, right? The slow step's rate law is K2 CH3 CH3. But the thing is that you cannot have an intermediate in your rate law because you can't directly measure its concentration. So we're gonna divide K1 so we can isolate this term and then plug it in there. So once you plug this entire term in here, you're gonna get K1. Yeah, so K2 times K1 equals CH3 H over K1, right? And that's the rate law. And this becomes all one constant. So the final rate constant is K CH3 COH3 times H plus. And your answer is A. Moving on, 26. So the question says, a rule of thumb is that a reactions rate roughly doubles for every 10 Celsius increase in temperature. What is the activation energy of, so the key thing to realize is that, so your concentration is constant, right? So if your concentration is constant, what increases the rate if the temperature is increased? It is in fact the temperature, and when your temperature will double K, because the rate law is K rate constant times a certain concentration, and concentration is constant, and if you want to double the reaction rate of the reaction, K must double. So we're going to use this equation, the Arrhenius equation, EA over R in joules, T1 minus T2, right, in Kelvin. So our rate doubles, right? So we're going to assume that our rate constant is 2 and our first rate constant is 1, right? And then you're going to solve for the EA. I want to just plug. You will get 52.9 kilojoules per mole. And the answer is again A. Moving on. 27 is a very weird question. It's like kinetics question is like something always new they'll bring out. So you better keep your toes on it. Like the questions can be really easy or pretty hard. This is one of them. At 650 K, beta-pinene isomerase is to form either 4-isopropyl methyl or myserine. The former reacts at rate constant 0.22 and the latter has the rate constant 0.13. What's the overall rate law for isomerization? So beta-pinene goes into like 2 reaction pathways, right? And isomerization is usually a first reaction. So since there's 2 reaction pathways, you have to add the rate constants. So the overall rate is this. Overall rate is equal to 0.22 first reaction pathway and 0.13 0.35 seconds, and their answer is D. But why do we add them? Because isomerization is like usually first order, right? So if you add them, you're taking into account the two reaction pathways. Like, so one may be tempted to multiply them, but like if you multiply them, right, that means it'll imply a second order reaction, because if you multiply 0.22, it's a weird question. It's a very weird question. B, right? This will form squared, and this will imply a second order reaction. So I think this is how it goes. I don't like this question at all. I just think it's very weird, but yeah, it's the USNCO. So yeah, so the answer is what? D. '28. How is the rate of change of the ClF3 concentrations related to the rate of change of the F2? Now this is, like I said, there's some very easy questions. Okay, so CF3 concentration increases and the F2 concentration decreases, because CF3 is a product and F2 is a reactant. So you can easily cross out A and B because there's no negative sign. And as you can see, right, C is the correct answer, because yes, it tells us the correct thing, right? As F2 decreases, CF3 increases, and CF3 increases at a lesser rate because this coefficient is 2 rather than 3 of fluorine. For every 3 fluorine that goes away, 2 ClF3 forms. So that's what this expression or equation implies in C. D is wrong because it implies the opposite. So C is our correct answer. Moving on. 29. A reaction takes place by an uncatalyzed pathway whose reaction coordinate diagram is shown below. The reaction is accelerated by a small amount of catalyst, which reaction coordinate diagram? This is not a straightforward question. So, okay, a catalyst like lowers the activation energy pathway. So if you have this reaction pathway, a catalyst makes this hump or the activation energy smaller. So which one it does? A doesn't change anything, which a catalyst changes something. B is wrong because a catalyst always the catalyst doesn't raise the activation energy. C is correct because it provides an alternate pathway, right? And it lowers the activation energy down. So since it provides an alternate pathway, there could be two humps, but they both have a small activation energy. So C is the correct answer. I know, but D. Okay, D is just plain weird. I guess it lowers the activation energy, but it's too unusual. So D is wrong. I mean, there could be negative activation energies, but it's very rare. Okay, 30. Metal iodide reacts irreversibly with azodine in the rate KCH3I and 3-. The reactions carry out initial concentration CH3I. Which statement about the reaction is correct? So, alright. Okay. The time it takes for CH3I to decrease to 0.5 is independent. No. If there's more, see, it's implying the rate constant, right? If the N3 increases, right, the rate must increase, right? No matter what the concentration is. If there's a higher concentration of a substance, the rate will go faster. So 30 is A. 30 is wrong. I meant A is wrong. A is wrong. Alright, let's skip B. Let's move on to C. The rate of the reaction rate is significantly smaller if excess I is added to the solution. Excess iodine is added to the solution. No. This is not about equilibrium. This is about reaction rate, right? And there's no ignore by Lee-Chatter's principle when you're doing reaction rates. In the rate law, there's no iodine, so C is an easy cross out. The reaction cannot take place in a single elementary step. So by taking a look at the rate law, right? The rate law powers match the coefficients of the stoichiometric reaction. So yeah, so the rate law implies that the reaction could take place in a single elementary step. And also, if you're familiar with organic chemistry, this reaction is an SN2 reaction, a bimolecular reaction, so it will take place at one step. So you can cross that at D. So I think this is like more of an elimination process thing. If the initial concentration of azide and CH3I are equal, then it takes half as long to decrease, yes. Because if CH3I is equal to N3, right? It's like forming a second order reaction because these two are the same. So then it'll form somewhat like a second order reaction. And that means it'll have a non-constant half-life. It'll form a non-constant half-life. Like this answer choice implies. So B is the correct answer. The molar solubility of lead fluoride is 2.68 speed. Okay, pretty simple question. You know the 4s3. Yeah, so 4s3 and then you just plug in 2.1 and you get 3.7 10 to the negative 8, which is C. Moving on, simple straightforward question. What is the pH of a 0.10 mole solution of ammonium acetate? So this is an amphoteric salt, right? Okay, before I do using the equation, if you take a look at the Ka and Kb, right? They're both of equal strength. So they'll both be supplying, quote unquote, supplying the same amount of hydrogens and protons and hydroxide. So the pH will be around 7. But since it's an amphoteric salt, right? NH4 acts like an acid and CH3OO acts like a base. You're going to use this equation. I'm not sure how it's derived, but pKa1 plus pKa2 over 2, right? So pKa of the acid and pKa of the conjugate acid of CH3COO. So then you plug it in, 925 plus 474 equals 0.700, and that is C. Hard question. 33. A closed container at 450 Kelvin initially contains only PCl5 and PCl3, each at a partial pressure of 2.7 bar. After the system reaches equilibrium, what's the partial pressure of Cl2? So this is a standard equilibrium question. So we're going to do RIC, your typical rise, PCl5 equilibrium with PCl3 plus Cl2. It starts with 2.7. Now if you want to check which way the reaction goes, since Cl2 starts with 0, right, the reaction quotient will be 0, and the reaction quotient will be less than the equilibrium constant, so the reaction will move towards the right direction, forward direction. So we're going to do Now I'm going to put into your equilibrium. X 2.7 plus X. That's algebraically, this is a pain to solve. So what you should do is just plug in the answer choices. And when you plug in, right, to see which ones will equal this value, it turns out, if you're lucky, if you choose A, X will equal 0.015 bar, which is A. Which is A. Which is A. Alright, 34. Which change will decrease the number of moles of Cl2 present in the system at equilibrium? Alright, let's take a look at our equation. So if we increase the volume of the container, right, it will shift to the side of it, shift the reaction side with more moles. So that means more Cl2 will form, and then the A is wrong. If you increase the pressure by injecting argon, that really has no effect on the equilibrium. Although it increases pressure, has no effect, because it doesn't affect Q. Increasing the pressure by injecting PCl5. If you inject PCl5, that means Q will be less than K, because the reaction quotient's denominator increased. So look for more products to increase the numerator. So they'll increase more moles of Cl2. So C is wrong. Now D is the answer, but it's a little bit more obscure how you get it. Because, okay, let's take a look at K. K is less than 1, 0.015. But that means delta G is greater than 0. Now, entropy of the system increases, right? Because 1 mole of gas forms 2 moles of gas. So if the entropy increases, right, that means delta H must be endothermic, right? Because if delta G is greater than 0, and if delta S is greater than 0, that means delta H must be endothermic. To justify this mathematically, use the equation delta G equals delta S Ts. Just use this equation to justify this mathematically. And since because of these we know that the reaction is endothermic, delta H is greater than 0. If the temperature increases, K will increase, and if the temperature decreases, K will decrease. So if you decrease the temperature, less products will form because the equilibrium constant decreases. So D is our answer. Moving on. Sorry, that's my brother if you can hear it. Okay, 35. 35 is a very good question. I like it. Like, these problems will appear more, it's more of a math type question, but it's good. If you don't know chemistry, haha. So a metal M forms a sparingly soluble sulfate salt. The logarithm of the concentration of dissolved metal ion in a solution saturated in the metal sulfate is plotted below as a function of the logarithm of the concentration of the sulfate ion solution. What's the formula? Okay, I think there's 2 ways to solve this. I'll show you one way because I forgot the other way. Maybe I'll list in the comments down. The way I solved it is, okay, so you know your Ksp, right? Your Ksp equals to metal M, right? And then you're going to have SO42 minus N, right? And if you get a log of both sides, you get log Ksp equals to, using your logarithm rules, this can be written as like this: M log M plus N log SO2 concentration of SO24. Right. Now if you write a linear equation of this, you'll get, so the slope is around negative 0.5, right? So over here, the centimeters. So log of m equals around negative 0.5 log of SO2 4 minus, and the y-intercept is -1. -1, right? Now, if you put log of m, if I isolate -1 to the side, log of m plus 0.5 log of S24, I found out that this will equal to this, right? And this will imply that the log of KSP is that. So then the KSP will be equal to around 0.1. And if you take a look at this, right, the m is equal to 1 and the n is equal to 0.5. That means the ratio of m to SO24 is 2 to 1. And I got A, or m to SO4. For these questions, a little maths involved in it, and these are the questions that make you think for a while. So, like, if you see them, don't be nervous. Just take your time and be calm solving them. Alright, 36. So 36 is a back titration question. So 36, back titration question. So let's begin. A 1 gram pill contains morphine, a monobasic compound whose conjugate acid has a pKa of 8.21. In addition to an unknown amount of inert material, to analyze the morphine content of the pill, it is dissolved in 50 ml 0.1 mole aqueous hydrochloric acid. And the unreactive acid in the resulting solution is back titrated with 0.1 mole NaOH. Which of the following statements about this experiment is correct? Okay, so number 1 is the back titration. So if you have 1 gram of morphine, 1 gram of morphine divided by the molar mass, this will give us around 3.5 times 10 to the 3 moles of morphine. Now, how many moles of acid are there? To analyze the morphine content of the pill, it is dissolved in 5.0 times 10 to the 3 moles of acid. So if you react, the unreacted moles of acid are 1.5 times 10 to the negative 3 moles of H plus. Now you're going to use a back titration to find out the back titration but NaOH. So the volume of NaOH needed is mole over m gives you liters. So then 1.5 times 10 to the 3 moles over the molarity times 1000 to give you milliliters will give us 15 ml. And the question says you need to require 35 ml. So then 2 is wrong. Now let's go to number 2. So methyl red, which changes color from red to yellow between pH 4.4 to 6.2 would be a suitable indicator for its titration. Now for number 2. So methyl red, which changes color from red to yellow between pH of 4.4 to 6.2 would be a suitable indicator for its titration. Yes, so essentially what the goal is here is that as we add NaOH, right, at the equivalence point you want a color change. So we can do this by, so if we have 1 gram of morphine, 285, I want to find the molarity. So at the end point, I want to find the molarity of the conjugate acid of morphine, or pH plus. So then we're going to divide this by 0.065 liters, and we will get 0.0539 molarity. Now from this you can calculate the pH. So using the pK as 8.21, you're going to find the Ka, which is this. Now you're going to just do your regular acid-base equilibrium calculation. X is small. And our X, let me calculate that. Our X is 0.43. Our X will be, oops, sorry about that. 1.2 times 10 to the negative 5 m of H plus, and this will give us a pH will give us 4.739. Now the implication of this pH is that as you titrate, as you let more OH into the system, the pH will rise. And once the pH rises, right, at the indicator, right, the indicator will tell us if that all of the HCl has been neutralized, which this pH does, because this pH is in the range of 4.4 to 6.2 of the indicator. This pH is at 4.4 to 6.2 of the indicator, right? So that means as you add more and more NaOH, right, the end point will have a pH of this, which is in the range of the indicator. So yes, this is a suitable indicator for this titration.